Markus.
Hello.
Hello. Welcome to the program.
Nice to be here. Thanks for having me.
So Markus is an independent consultant and a frequent speaker at conferences.
Much too frequent, yeah.
An author.
Yes.
And best known for work on model-driven software development.
Right.
And domain-specific languages.
Yeah.
So Markus, tell us a little more about you.
Okay, well, as you said, I'm an independent. I live in Germany, a city called Göppingen, which some of the audience might know because there is this company called Märklin who builds those world-famous model trains. Otherwise, the city is irrelevant. And I spent my time traveling around, mostly in Germany, also internationally, helping people use domain-specific languages, code generation, model-driven development, meta-modeling, these kinds of things to build applications and systems.
Can you define model-driven software development?
Before I define model-driven software development, I would like to define what the DSL stuff is all about, because I think MDSD is a subset of that. Okay. So domain-specific languages is about basically defining languages and notations especially that help stakeholders define a particular viewpoint or aspect or concern of a system. Formally define, in the sense that you can use this information that's specified via the DSL and either interpret it and affect side effects or generate stuff from it or validate things or simulate stuff. Okay. Now, you can do this DSL stuff in various ways. There are two mainstream ways. One is external DSLs, where you have your DSL in a separate editor. It's not related to any programming language, except that you maybe generate programming language source code from it. And then there is internal or embedded DSLs, where you embed the DSL in a host language. Ruby is most known for that. So in Ruby, because of its flexible syntax and its metaprogramming facilities, you can tweak stuff so that a Ruby program actually looks like something that is not a Ruby program, although it is. Model-driven software development focuses basically on these external DSLs and mostly on generative approaches. I did projects where we interpreted the models, and there is no technical reason why you can't, but typically it's generative. So you have a model, it could be graphical, it can be textual, whatever. You have a nice editor for it, more or less nice. You generate code from it, you execute the code.
Now, how does it mesh with approaches like domain-driven design, in your opinion?
As I said, model-driven DSL stuff is about building languages for expressing certain concerns of an application of a system. That concern can be anything. It can be business stuff, can be architectural stuff. I do quite a lot of projects with formal component models, so you can generate all the technology crap code, right? All the stuff you have to write. You can express non-functional concerns, all kinds of things. Now, domain-driven design explicitly focuses on defining a language in a non-formal way for expressing the core complexity at the heart of the software, as Eric, I think, expressed it once. So it's about building a language for the business person. And in that sense, of course, you can use domain-specific languages and MDSD to address the business concern. In that sense, it's kind of larger because it's not limited to business. But there is also a viewpoint where you can say that domain-driven design is larger because it doesn't just talk about defining this language for talking about a business. It also gives you concrete advice about how to implement it, repository entities, all that stuff, and anti-corruption layer and all this kind of stuff. MDSD doesn't really talk about that. Well, sure, you will have, if you design it well, you will have layers and you will have technology stuff down there, and you have nice APIs and technology, let's say, independent stuff further on top, but it's not explicit in the approach. So I think that if you take DDD as the given from which we look at domain-specific languages in model-driven development, then DSLs and MDSD are a way to, well, if I try to be very pragmatic, first of all, define a maybe nicer syntax for the domain language that DDD comes up with, because you're not limited by Java, right, which has a very rigid syntax, and it helps you implement some of that language by generating stuff, and you don't have to try to use more or less awkward language means to somehow get from the nice business language down to implementation code.
How does it relate to MDA?
So this is my opinion. I'm sure the OMG has the opposite opinion. So I think MDSD is the general approach. It basically says you define a meta model, which defines your language formally. Then you go ahead and define some kind of syntax for that meta model. So you come up with the language, abstract syntax and concrete syntax. And then you define basically a mapping onto something with known semantics, which would be a programming language typically, and you generate. So that basically defines the semantics of your language. So you always have these three ingredients if you define languages. So this is a very general approach. MDA basically takes this idea and standardizes some of its components. For example, if you want to specify a meta model, the way you do this is by using the OMG's standardized meta model, which is basically a meta model for defining meta models. Well, it's not that complicated. I mean, it's just one level higher. So the MOF is basically a language for defining meta models. Mm-hmm. So if you want to be MDA compliant, you have to define your meta models using MOF. Same thing is if you want to be really MDA compliant and transform models into other models, the OMG has a standard called QVT, Query View Transformation, so that's what you should use. If you want to generate code, there is a standard. I'm not quite sure if it has been finalized yet, but it's certainly in its final stages called MOF to text, which is a code generation standard, and so on. So that's kind of the theory. So in that theory, MDA is a subset of MDSD in that it somehow specifies not just what you do, meta model, syntax, blah, 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 but also how you do it, and provides certain standardized approaches. Now, in practice, it's a little bit different because although in theory you can have any DSL built on top of MOF, what you really do in practice, because of the reality of the tool market, is you build a UML profile. So in practice, MDA means you take a UML tool, you define a profile, tweak your UML diagram by changing the meaning of the symbols, by attaching stereotypes and tagged values and using constraints, and build your domain-specific language this way. And people argue, I like to argue about that, whether this is a good way of doing it and whether UML is a good language. And so, for example, just one detail, if you generate code from a UML diagram, you obviously have to understand the UML meta model, the language definition. And the UML meta model is extremely complicated. And if you add a profile to it to make it more specific to your domain, you can't remove any of that. So processing a UML model, even if it's profiled and hence somewhat domain-specific, is still a pain. So that's why using UML for that kind of stuff is not always the best choice.
Right, not that expressive to begin with.
Well, I mean, in theory, you can make it as expressive as you want. You can represent every information as a typed graph, okay? And since a class diagram, just for the sake of example, is a graph, it has boxes and it has lines, you can express everything with it, but it's probably not a good syntax. So that is something that really needs emphasizing in the MDSD discussion, that although it has the model in it, a model doesn't need to be graphical. You can have textual languages, and for many aspects of system development, they are more practical. All the CVS diff merge is way easier with textual languages. Graphical languages are good if you want to show relationships between stuff. There is no point in describing a state machine textually. The same is true for data structures. I mean, clearly, things like ER diagrams are useful to get the big picture. Right. So I emphasize this textual stuff because in the whole MDSD, MDA world, people always think graphical. And one reason why that is or was the case was simply tools. For example, with UML, you can easily build your own DSL tool. It might look crappy because it's UML-based, but you can do it. With Eclipse GMF, you can build your own custom graphical editors, and that's now more or less mainstream in the Eclipse world. There is no mainstream tool for building textual editors, with code completion, syntax highlighting, custom constraint checking as you type. These tools are coming along. One of the tools, Open Architecture, in its overall set of tools, has a tool called Xtext, which allows you so you specify a grammar, press a button, and what you get is a nice Eclipse editor with all the bells and whistles. You can customize it with your own constraints that are checked at editing time. You don't even have to save, it's in real time. And it gets you a parser that can parse the textual syntax, build an EMF representation of it, and then you can generate from that, for example. Absolutely pain-free, really good stuff. So because those tools are coming, the emphasis on textual DSLs increases. Of course, you can argue you've always had those tools, Antler, Lex, Yak, but they don't give you editors. And if you don't have an editor, nobody cares.
So in the last few years, there has been this growth of 3 and 4 letter acronyms containing varying number of letter D in them.
Yes.
So another D containing acronym is MDD, which is model-driven design.
Same thing. So just to resolve the problems, there is model-driven software development, MDSD. That's the term has been defined at UPSLA 2003 and is also the title of my book. There is MDD, which is exactly the same thing. There is MDA, which we talked about. There is generative programming, which, well, I tried to find out recently by talking to Krzysztof Czarnecki for the SE Radio podcast what he thinks the differences are, and he had a little bit of a hard time. So it's, for all intents and purposes, also the same thing. Right? There are software factories, which is a bit larger. It's the whole product line stuff a la Microsoft, but there is the DSL tools in it, which is model-driven software development. And then there's domain-specific modeling with full code generation, as the meta case folks like to call it. Same thing. So
MDD in this case stands for what? Model-driven design?
I would call it model-driven development. I think that's
because I'm trying to get to what Eric Evans defines MDD as, which is model-driven design, and this is what sort of domain-driven design is about.
The difference is that Eric's notion of a model isn't necessarily formal. So there is this idea that you have this model of the world in your head, and all the code should resolve around this domain model.
Right.
And that's a valid thing. And in some sense, you could argue that it's an evolution. You start with, let's say, Eric's stuff, right? By having domain-driven design, you have this model in your mind. You try to express this model as well as possible in your code. And then you go a step further. You maybe draw, in quotes, a formal meta model that formalizes that domain model, that domain language. I like to use model for the instance and language for the meta level. And then you can build a syntax that is maybe more suitable for the domain than basically a fluent API in Java or some Ruby quirks. But by the way, well, no, we shouldn't get into that. I mean, the Ruby stuff is very nice. I mean, it's really nice to have a DSL kind of thing integrated in a host language, because you can always easily escape to the host language and you get symbolic integration. However, I recently thought about this quite a bit, why I kind of have somewhat of a bad feeling about this Ruby stuff. And the reason is this. If you want to present your domain-specific language to a domain expert, then he needs two things. One is immediate feedback if he types something that doesn't make sense. And at editing time, not when you run the program and you get some strange Ruby message or Java error, compiler error for that matter, right? That's one thing. And the other thing is that, of course, if you have worked with Ruby, because it's a dynamic language and because the language doesn't know about your DSL, since it's all meta stuff, you don't have code completion, any of that. So that's why I think if you target the business expert, external DSLs with the appropriate tool support are better suited. If you have DSLs that are targeted towards the developer, like Rails, for example, then a Ruby solution is, well, obviously it works, it's perfectly okay. Without any religion there, I think there are just trade-offs, and I think static error checking and validation is very valuable for people who are not necessarily used to express themselves formally and precisely, which would be domain experts.
Okay, and so I wanted to go back to domain-driven design. One of the approaches that domain-driven design gives us is strategic design. These things are, I mean, they are probably quite orthogonal to MDSD, right? Because these are just methods of defining certain types of models in contexts.
So strategic design, I understand that to be more or less architecture.
Well, yeah, I mean, basically one of the parts of it, the context mapping, has to do with the fact that there are multiple models on any project, and we recognize that fact, and we name them, and figure out what the relationship is.
So I think there are two aspects here. One is that, as I mentioned before, and as you also implied, you have various viewpoints to describe a system, and you have to describe the overall system by having instances of each viewpoint. I don't know, data structure, database mapping, component infrastructure, whatever. And so if you have separate DSLs for each of those, you need a way to integrate them. Right. And that's, well, it can be a challenge. So again, it basically gets down to tooling. So just for the sake of the example, if you express all your DSLs in UML, in one big UML model with many diagrams, integration is no problem. It's just there. If you do, for example, textual DSLs with, let's say, the OAW XText tool, then you can have references between languages and between meta models. So it's no problem to say you have maybe a DSL or a model that describes the mapping of certain business data types to a relational table, although you might probably want to do this with Hibernate anyway. So you, from this persistence mapping description, you can kind of point into the other model. And the way the pointer works, well, in the worst case, it's name convention. And if you load the model into the generator, it checks for consistency. Or if you have more sophisticated tools, you can really use pointers. So for example, I'd just like to briefly mention the intentional stuff. So what the intentional folks are doing is they have this central, what they call intentional tree. So they represent everything as instances of this tree. And then they project the notation. So instead of parsing text and building the tree, they have the tree and project the notation. And since everything is stored in this central tree, it's easy to project parts of that tree into different notations, in different, let's say, diagram kind of things, or different sections of things that look like text, or whatever you use as a notation. And therefore have various notations, various viewpoints, and still one big integrated model that has pointers between the various viewpoints. So that's just a tooling problem that is resolved to various degrees. The other thing, of course, is that although you have this nice domain language and everything is well and everything is nicely integrated and beautiful and stuff, you still have technology stuff below it. And another benefit of MDSD and the generative approach is that you simply write a generator that handles this stuff. So I'm really not willing anymore to implement EJBs or any stuff manually.
Which is what I wanted to ask. Was MDSD in any way motivated by or spurred by the crazy difficulties of having to use J2E stuff, the EJB stuff?
Well, I mean, to be fair, you have to see that MDD is way older than all the EJB stuff.
Okay.
I mean, it has been done in the embedded world for ages. However, the argument you make is that there is a platform that, well, sucks, okay? That requires a lot of boilerplate code to be written so you can use it. And of course, the more of that stuff you have to produce that somehow can be derived from an intent, right? A model that describes what you want to do, the more there is the more it makes sense to have a generative approach. And in the embedded world, traditionally, this has always been the case. Many embedded operating systems are, well, I mean, are not necessarily very user-friendly on the level of application programming. And also, you typically don't just write the program, you have to configure operating systems, resource management, all that kind of stuff. So you have various cross-cutting concerns scattered over all kinds of files, programs, things. So raising the level of abstraction and generating all that stuff is a good thing. And in the enterprise world, I would agree that it certainly got a big boost from bad platforms. However, I've used this approach in context of Spring and other not so bad frameworks. So, you know, the point is this. Model-driven development gives you several benefits. And without explaining each of them, it's having a nice syntax. You can validate semantically on model level. You can automate code generation that would otherwise be boring. The architecture becomes better because it's kind of more standardized because you put the idioms and patterns into the templates, the code generation templates. So there are various benefits. And which of those is the most important in a given setting depends. If you have a bad platform, then generating all the stuff is maybe the most important benefit. If you have a good platform, then being able to have the domain expert integrated better because the notation is nicer might be the biggest benefit. So it depends why you do it.
Okay, so with MDSD, do I care about things like repositories, for example? So, yeah, let me...
Do
I ever get down to that level?
Yeah, well, sure. I mean, so there are two things. First of all, in some sense, what this entity repository, I think it's called dependent object. I always forget the other one, the non-entity value object. Sorry, yeah. That is just a meta model. So let me say this: if you build an enterprise application, and that's clearly what domain-driven design is more or less focused on, the meta model proposed by domain-driven design is a good one.
Right.
And it's also, I'm not saying it's like trivial, but it's easy to see that this makes sense. If you work in another domain, embedded stuff, or in image processing, you have different central metaphors. And for example, things like pipes and filters. So you have to come up with a sensible meta model for your domain. And for the business domain, I think the meta model proposed by Eric in the domain-driven design book is a good one. However, it's also a relatively simplistic one. And that's in some sense good. But also, if you do model-driven design or model-driven development, you confused me. You can, of course, have a richer meta model with more specialization, more relationships. So what I do is, yeah, sure, you still have the notion of a repository. You still have an API that people in menu. So typically, you don't generate the whole application. You still have parts that are manually written, and it is key to successful MDD that you have nice and well-defined APIs against which you write the manually written code. And the repository itself is such an API, but I will probably generate the implementation of the repository because that's kind of trivial. I don't need to write this manually.
So, Markus, do you have anything else to add to this?
I would like to see the domain-driven design community and the agile community in general be a bit more open towards some of these things. I see that the agile world likes the DSLs if they are implemented in Ruby, and only if. And I like to joke about that. If you have internal DSLs in Ruby, you're agile. If you have external DSLs, well, you have to be a little bit more persistent, so the agile people believe that it's agile, because they always think code generation is evil, you can't read the code, which is stupid, you write the generator, you decide how bad the code looks. You have these big, huge external tools for defining languages, which is rubbish. I can define a nice textual DSL within 15 minutes. So it's really nice, small, and agile. But there is this kind of barrier a little bit in mindset. So I would like to see this more integrated.
Okay. Well, thank you very much, Markus.
Thank you.
It was an honor to have you. Thank you.
It was a pleasure. Thanks.